you all for hanging in there. So I'm going to try to be fairly short because the two gentlemen sitting to my right know far more about stormwater than I'll ever know. And I'm going to just try to set the stage for the discussion about certification verification programs and then turn it over to Kurt and Chris. That's the wrong button. That button. Okay, there we go. So here's, yeah, we're going to do that. So here's the outline of what I want to cover in the next few minutes. Talk a little bit about, so the theme of this next half hour, 45-minute session is about certification and verification programs. This has already been teed up by many of the earlier speakers, and the obvious point to be made is you can't have 40 or 50 or 60 different certification systems for any technology in a country, or you would drive the vendors nuts, if not out of business. So we need to get beyond that. We'll talk a little bit about when we talk about certifying or verifying technologies, what exactly does that mean? And in particular, this question of scale. And I'll say more about that in a minute. And then one of the things that was teed up in a couple of the earlier talks is we want to make sure that when we're investing all of this money in capital and urban systems, that the capital has lifetimes of decades, that we're actually building something that's not only going to address the current day problems, but anticipate and hopefully avoid problems in the future. Something else to think about. So, starting on the first point. So why do we have a certification or testing program for anything? The first obvious point is that we want to make sure that when something is in the marketplace, something that is being applied to solve any kind of issue, that you're not buying snake oil. And this is not a direct comment on anyone in the room or anyone in the profession, but I think we've all had the situation where you get these phone calls and you have some issue in your organization and somebody's going to sell you magic beans, and magic beans are going to solve your problems and grow hair and everything else, and by the way, they're really cheap. So we need some system to make sure that there's vetting of new products that we come onto the market. Underwriters Laboratory is a good example of that. So the obvious reason you have a certification program in a sector is to make sure that what's in the marketplace is actually going to work as advertised. But there's other reasons as well. Reducing uncertainty and enhancing uniformity across the marketplace is incredibly important, particularly as we're trying to attract new technologies into the marketplace. So avoiding the Tower of Babel, not having every state, every jurisdiction talk about better than basic, all these terminologies that come up, irreversible solid flows, which I always thought was amazing. This kinds of language, if it sits at the state, county, regional level, and vendors are meant to work across those jurisdictions, they're going to have a heck of a time competing in that marketplace. So uniformity is a big reason for having certification and verification programs. The final reason, the broad reason to think about why we do this in the first place, is to allow access to markets and therefore innovation. Hopefully you'll recognize these screenshots from. You need the lights down to bad as the lights in here. Steve was sitting next to the lights. He didn't respond accordingly. Steve. So obviously we have people outside of the castle looking at wanting to come in. They have a new product. They have a new technology to bring to market. You have of course the French are up on the ramparts looking down at them and making fun of them. The certification program, if it's done properly and is accessible to small businesses and entrepreneurs, that gives them the credentials to enter the marketplace. So that the credentialing program has to be affordable and has to be user-friendly enough so that someone with a great idea can get certified fairly easily, or at least quickly and inexpensively. So certify what? What are we exactly talking about here? The current approach, the TAPE approach, and the other certification programs around the country that Kurt Marx is going to say much more about are asking a really important question. That is, does a device work as advertised? And not picking on anyone, I just pulled one of the example treatment technologies. But basically, the certification programs are asking the question: does the device work when it's brand new and when it's installed properly and when it's operating properly? That's a really important set of questions to answer, and I'm not saying we shouldn't be doing that. That's exactly what we need to do. The point I want to make, though, is that is not enough, because knowing that a single device works, it's not necessarily going to tell you if you're going to be able to solve your problem with the technologies that you're installing. I think the important question, or another important question we haven't even begun to address, is not does a single box work, but does a family, the portfolio, the network of boxes work in a community? So here's probably a poor quality map taken off the NEMO, because the NEMO database is bad graphic arts on my part this morning. That's the state of Connecticut and LID installations in the state. We don't really have very good tools, models, analytical tools, to assess whether or not is that enough LID? Is it too much? Are they in the right place? Are they the right times in the right place? You can imagine playing the game, perhaps if you had the right tool, you could do it quantitatively, of saying, I have a fixed budget, I have a fixed number of LID installations that I can put in the city of Tacoma. Should I put them all in one neighborhood? Should I string them together? Should I distribute them evenly? We have almost no quantitative tools available to us to ask that very important question at any scale beyond one or two of these things pulled together. So that's a significant challenge for us. Those models, those analytical tools need to be certified and validated every bit as much as a single device does. We don't have a program for that. So when we start talking about national programs, I want to make sure that we don't forget this other need. Okay, the final point, and I'll turn it over to Kurt. Solving current problems is, of course, incredibly important. I assume almost everyone in this room is employed to solve current problems. But some of us at the universities and others places get to anticipate future issues and try to make sure that we're not painting ourselves into a corner. Let me give you an example of that. So, the current treatment systems that we're working on now, that we're installing throughout the United States for stormwater, they alter flow, they remove solids. By the way, they remove the pollutants that are associated with the solids side benefit. You get to get credit for that. Do a decent job, not great sometimes, but a decent job of reducing nutrients and dissolved metals. You've seen some of that data today. We can absorb metals through ion exchange onto solids. It's pretty well known. Oil and grease and things like that. Most of this stuff is driven by the priority pollutant list, which dates back to the 1980s. And that's fine. These are important pollutants. They cause problems. We need to keep them out of our waterways. The problem is there's a lot of other chemicals in the world. So the question I ask is, are the systems that we're designing and installing now, which have half-life or lifetimes of decades, will they be protective of problems in the future? Let me kind of tee that up. Here's a chemical that you probably many of you have ingested today. It's probably sitting in the back. This is a chemical called sucralose. It's a man-made chemical. They basically have taken sugar and they chlorinated it. And they put it in a little yellow packet and they sell it to you. It's splendid. Now it turns out that adding chlorine to the sugar molecule prevents it from being metabolized by your body, so there's no calories in it. Not being metabolized, and it passes right through your body, it ends up in the waste stream. It goes to the sewage treatment plant, it plugs in the sewage treatment plant, chlorinated sugar, I don't know what to do with that either. They pass it on out, it goes out into the environment. We go out and we collect water samples all over Puget Sound, and Splenda is in the surface waters of Puget Sound in space. This is some work we did this summer, a whole bunch of partners from around Puget Sound. Take-home messages that in 95% of the surface water samples collected in Puget Sound this summer had Splenda at measurable concentrations, a few nanograms per liter kind of thing. These are the kind of chemicals that, my message is I don't want to sit here 20 years from now in the same room and have a conversation about, gee, how are we going to remediate Splenda out of Puget Sound? We need new control technologies. Let's not do this again. And you may think, well, Splenda is pretty safe stuff. We eat it. How bad could that be? A lot of these so-called emergent contaminants are now being shown to cause impacts on organisms. And this is an incredibly important paper that was published earlier this year from a group out of Sweden, where basically they first measured the concentration of this chemical, which is an anti-anxiety drug prescribed in high dosages and high frequency of dosages in the United States. They measured it in rivers in Sweden. They dosed fish in the laboratory at the same levels of this anti-anxiety drug that they're seeing in the environment, and they measured changes in the behavior of the fish. The fish actually became less anxious. They became more bold. Same thing as, and you may think that's probably worse, Jen. Jen can tell you, if you change the behavior of a fish, you screw up its ecology. So these fish became very bold. You might think being bold as a fish is a good thing. Not if you're a little fish and you're living with a bunch of big fish. Being bold is a great way to die. So the point is we're seeing chemicals in the Puget Sound and elsewhere. These chemicals are water soluble. They don't absorb onto solids. They're not going to be retained by the LID systems that we're putting in the water now. We're putting in the system now. So we should be thinking about these things. All right, I'll summarize and I'll turn it over to Kurt. So certification programs are obviously important. You're going to hear more about that in a minute. We desperately need a national strategy. We need the other Washington, as I like to say out here, to step up and drive a national program. The conversation's already started about how to do that, and Chris is going to talk about that. We need to develop these tools so we can assess the aggregate behavior of these systems that we're putting in the ground, so that we can speak with certainty about the impact that they have. You know, the skeptics in the crowd, and I'm one of them. I'm not quite sure LID that the LID emperor has as many clothes on as you might think. I'm not sure you can put enough of that stuff in an urban area to really bend the curve on stormwater, but we can have that conversation. And then finally, these new chemicals, so-called emerging contaminants that we're seeing in the environment, we should be building infrastructure now to address those chemicals today rather than trying to do it later. So with that, I'll stop and I'll turn it over to my colleague Kurt Marx, who's also at the Center for Urban Waters. Kurt.
Good afternoon. My name is Kurt Marx. I'm with the Center for Urban Waters with the University of Washington, Tacoma. And like Michael said, I didn't wake up one morning thinking that I wanted to get into the stormwater arena either. However, as a graduate student at UW Seattle, I did wake up and decided that I needed to get in-state tuition somehow. So I ended up at being a research assistant with a professor, actually working on the I-5 Ship Canal stormwater treatment testing facility that Larry showed us earlier. I was working on some planning for that even before that facility was built. So here I am 15 years later, still in stormwater and now back at UW. So today I'm going to talk about Washington State's stormwater treatment certification program. Some of you may have heard us mention TAPE today. I'm going to explain a little bit more what that is and why it's needed. I'm going to go over the history of the program, talk about some field testing in Western Washington, and some of the companies and technologies that are in that process, and then also discuss why it's not just a Washington State thing. So TAPE, some of you may know what it is, some of you may not. This isn't the TAPE that we're talking about. TAPE is the Technology Assessment Protocol Ecology. The E is for ecology, and TAPE is a Washington State Department of Ecology program that they've been operating for several years. And the technology in TAPE is referring to emerging stormwater treatment technologies, or BMTs. So briefly, history of the TAPE program. Back in 1999, so we've been doing this a while in this state. This isn't something that's new to us. In 1999, several members of the American Public Works Association, Washington chapter, the Surface Water Managers Committee meeting, they're still around, they still have meetings. Back in 1999, they decided that there needed to be a system to vet new stormwater treatment technologies that were coming out on the market. So they put together some preliminary processes to achieve that purpose. In 2002, the Department of Ecology, realizing that this was a statewide need, they adopted the program and published their first guidance manual on how this process worked. In 2004 and 2008, the guidance document and the process were slightly updated. And then, unfortunately, in May of 2008, the TAPE program closed its doors to new applicants due to budget and staffing constraints. However, fortunately, a couple of years ago, in January of 2011, TAPE reopened with a revised guidance document and reopened its doors to new applications for new stormwater treatment technologies. TAPE was reopened as a partnership between the Department of Ecology and the Washington Stormwater Center. And as a few people have mentioned today, the Washington Stormwater Center is a collaboration between University of Washington and Washington State University. And one of the 4 programs within the Washington Stormwater Center is the TAPE program. This is our program where we assist and work with Department of Ecology to implement this program. So why do we need TAPE? I'm going to start at the top and kind of funnel my way down to the bottom of why we need tape. We've mentioned and talked a little bit today about the Phase 1 and the Phase 2 Western Washington Stormwater Permit, and these permits regulate 80 plus counties, cities, and ports in Western Washington, and one of those requirements is to treat stormwater in certain situations. Damon mentioned the big, thick stormwater management manual for Western Washington. It is very thick. Part of that manual, the permit refers to that manual for how to implement and design certain stormwater treatment systems that would be required for development and redevelopment situations. However, that manual is only updated approximately every 5 years or so, and it doesn't include any information on proprietary or private company devices in that manual. So because the ecology wants to be able to implement and use these technologies, to have us use them, they have the Stormwater Management Manual defer to the TAPE program for the approval of new treatment technologies. So via the TAPE program, stormwater treatment technologies that are approved are kind of inferred to have approval in the Stormwater Management Manual. So the TAPE program, what kind of pollutants are we talking about? Joel talked about some of the future pollutants that we may be dealing with. Jen talked about PAHs, which is an upcoming pollutant source. TAPE deals with some of the more basic pollutants. It looks at certifying treatment devices for the removal of sediment, metals, specifically dissolved copper and zinc. Those aren't salmon, those are walleye and perch, because I grew up on the Great Lakes, phosphorus, and oil. So traditionally, these pollutants have been removed from stormwater using systems like this: bioswales, detention ponds. This one doesn't have a fence, and there's the fence that who showed us the fence? Art, yeah. So these systems, traditionally, some places they work well, some places they don't. So why not always use those systems that we've traditionally used? For several reasons. They might attract vectors such as mosquitoes, they might be nuisances, they might attract children that want to get in them and do things that children do. Houses, land prices are expensive, especially in urban areas, and there's better, more economic things we can do with the land. Maybe we want to park more cars on it. So this is, I'm going to skip this slide, actually, because we've kind of talked about that today. So a summary of the TAPE program, where we're at today. Since the program reopened in January of 2011, there's been 3 treatment technologies that have been fully approved, and so that brings the total number of technologies in the TAPE program that are approved since the early 2000s to 13. The great thing is, and it's kind of surprising when I've added up these numbers, that currently there are 15 other technologies involved in the TAPE program at this time in various stages. Some of them have just submitted their initial applications. Others are developing their QAPs, or sampling plans, to conduct field sampling. Others are looking for sites to conduct sampling, and some are out there monitoring. If it ever rains here, they'd be monitoring, and others are almost on the verge of hopefully getting a general use level designation, the final approval, with their technical reports being reviewed. So there's 15 technologies that are slated to, in the next few years, to be accepted by Ecology's TAPE program. Some of the field testing, TAPE requires field testing of an actual full-scale installation in the field in the Pacific Northwest. TAPE is a Washington entity. It's owned by the Department of Ecology, and it works well for them. But sometimes with projects in different places, sometimes you might not be in Washington. So basically, Ecology opened it up to all of the Pacific Northwest, basically Western Washington, Western Oregon. These are some of the testing sites from Bellingham, basically up and down the I-5 corridor down to Vancouver, and including approximately 4 sites in Oregon that have been locations for testing throughout the years. So one of the biggest challenges for technology companies is to find one of these testing and installation locations. You need to have a willing site owner, whether they're private or public. The location needs to be physically capable of being monitored. It needs to, for example, not be backwatered by tides, and it has to be safe. If it's in, say, the middle of a busy highway, it's not going to be the best situation for an ongoing, robust monitoring project. Pollutant loading. You need to have runoff that has sufficient concentrations to show that your device can remove or reduce pollutants in stormwater. Fortunately, some sites do have clean stormwater runoff. That's great. But if you're going to be putting in your device to show that it can treat and remove pollutants, that's a site that you wouldn't want. And also just developing the collaborations to do this testing, local and state permitting authorities from the Department of Ecology down to the local city or county, the vendors, developers and site owners, engineers, scientists and consultants and analytical laboratories all have to work together to shepherd a product through the tape process. So these are, usually I don't get into a lot of the specific companies and specific products when I talk about tape, but today I wanted to. I just wanted to put some of them up here. Some of them are here today in the audience. Some of them have booths in the back. And the Department of Ecology's tape webpage here lists all of these companies and devices that are either approved through the tape program or are currently going through the program. So I urge everyone here, whether you're a municipality or a consultant or an analytical lab or however you're involved in stormwater, to open up a dialogue with these companies and be open to seeing if your facility could somehow collaborate with these to do some testing in the future. So who else benefits from tape? Obviously, the vendors want to get tape approval so they can sell more of their products, their business, and they want to make money. That's understandable. But other benefits, the Department of Ecology, their job is to protect water resources and protect water quality. So they want these technologies out there in the ground, but they want to make sure that they work. They want to make sure that they're not the snake oil. NPDES permit holders, cities, counties, ports, and their design engineers, it's more tools in the toolbox for them to use. Also, manufacturing, construction, engineering, scientific firms, analytical labs, they're all involved with developing, building, and installing these devices. And of course, the fishes or the environment. We heard 3 great talks from John and Nat and Jen about some of the toxicity issues. And the TAPE program is one of the few, and it might be the only certification program of a handful of certification programs in the country that certify devices for the removal of dissolved copper and zinc. And also economic development, this region being seen as a leader in stormwater management. So is tape just a Washington thing? It serves Washington well, and we've been doing it for over a decade. However, it's not just a Washington thing. Tape is used by several cities and other states, as shown on this map, to allow the use of treatment BMPs. Some of them allow testing done under the TAPE program to count towards testing under their program. So it's definitely known outside of the United States. And also, most of the vendors that are involved in the process in TAPE are actually from out of state. They're from several states in the country, many from Oregon. Michael is I think, one of 2 companies that's Washington-based, but they're from all over. So a recent article by Connor Dennehy with Blue Tech Research, this was in the recently, the first edition of the Water Environment Federation's Stormwater Management World Water publication. He estimated that the annual stormwater treatment equipment market in the U.S. is between $0.8 and $1.4 billion. Just billions, not trillions like our earlier speaker was mentioning. And then combining that with green stormwater infrastructure, the total is up to approximately $4.6 billion annually. for traditional kind of gray stormwater equipment along with green infrastructure. So I'm going to wrap it up. A regional perspective. The necessary resources for developing these emerging stormwater technologies can and are being provided and met in this region. We have interested technology developers. They're here today. Local municipalities, industrial sites, residential sites that are willing to host pilot tests, and a regulatory environment able to accommodate real-world testing. Part of the TAPE program, the initial certification steps basically allows the vendor to install up to 5 or 10 devices within Washington State prior to getting approved, because it's kind of the cart before the horse issue of, well, I can't install my unit to test it because it's not approved, and I can't get it approved because I haven't installed one yet. So that's the regulators allowing some flexibility. Also in this region, the capacity to test and certify these devices, the Center for Urban Waters, Washington State University's LID Research and Toxicity Lab, the TAPE program, WashDOT's involvement, several of the ports are doing a lot of great work, environmental firms, etc. And also our light manufacturing and engineering capacity, I think, is great in this area. And the Pacific Northwest is known for its rain, so I think we need to do this well, because you tell someone you live here and the first thing that comes out of their mouth is, doesn't it rain there all the time? All right, thanks a lot, and I'm going to hand it over to Chris.
Okay, I'm wearing a different hat for this part of the conference. I am here representing the Stormwater Equipment Manufacturers Association, and as mentioned earlier, I chair the Government Affairs and Regulatory Committee for SWEMA. And one of the initiatives that the group has been involved with over the last year and a half is engaging EPA and other stakeholders in regards to the idea that we need to develop a national standard for testing of stormwater systems, whether it be proprietary or non-proprietary systems. And the background that I want to provide a little bit is a little bit about who is SWEMA. It's a relatively new organization, but as many of us know today that the new regulations that are coming out nationally, whether it's regionally focused like the Puget Sound area, the Chesapeake Bay, or other high priority ecological regions, whether it's the upcoming stormwater rule that EPA is looking to implement at some point, regulations are getting tighter. New solutions are needed in order to address things and to be able to bring cost-effective solutions to the marketplace to help meet local, regional, and national water quality standards. And so SWEMA was formed in 2008 by a group of industry leaders and organizations. The membership of the organization itself is comprised of various interest groups. Primarily, you have manufacturing organizations such as Filterra, Contact Stormwater Solutions, and other groups of that nature. Many of those that were mentioned earlier. I don't have a comprehensive list here just for brevity, but it also includes organizations that provide maintenance services for stormwater best management practices. There's also an associate level and professional level for consultants as well as government entities who may want to become part of the organization in order to be able to better interact with folks who provide innovative solutions towards stormwater management. There are various committees that are involved within the organization. I mentioned earlier I'm the chair for the Government Affairs and Regulatory Committee. There's also a marketing committee, a group focused specifically on maintenance, and then there's also a technical committee within the organization that focuses on things such as developing protocols for stormwater monitoring. The mission of the organization itself is to be an advocate for effective and sustainable solutions for quality in stormwater while being able to provide educational outreach to the various stakeholders involved within the stormwater arena. The key values of the organization is that recognizing that the manufacturing sector does have a place within the overall treatment of stormwater, but that also all practices, regardless of where they're created from, whether it's the private sector or whether it's public domain systems, should be treated equitably, and that the testing standards for all these systems needs to be the same. And that emerging technologies must have a meaningful path forward within the regulatory atmosphere in order to be able to provide new solutions for addressing water quality issues. Like anything else, we all want to try to keep our eyes on the ball and recognize that we all have something positive to contribute towards environmental cleanup. More about SWEMA is available on the company's website. I would encourage folks at your discretion and as time allows to visit the website to be able to learn a little bit more about us. Recently, we've published a position paper regarding the proposed stormwater rule that EPA is going to be issuing in order to recognize that it's not just all about infiltration, but also water quality treatment, which is where stormwater historically has been focused, still has a role in the new generation of stormwater regulations nationally. So to really dive into the topic at hand is the need for why do we want to have a national protocol or something in place. And what this ultimately comes down to is that you want to have regulatory certainty. You pretty much are looking at roughly 51 plus different municipalities, jurisdictions that are going to have different standards to meet their different issues. There's little to no programmatic consistency between the different states as to what's been done. And if one thing I think that folks here have heard a message about today is that not only is stormwater monitoring complicated, it's also very expensive. You're probably looking at anywhere between $200 to maybe $500,000 for the effective monitoring of one site. That's influent, effluent, looking at the different parameters that folks want to address, and if we start adding new parameters in the future, as we must as an industry, then that's going to also increase the cost for analytics over the future. There's also different debates regarding the usefulness of field studies versus laboratory studies and how that plays out. But one of the key factors here is that there is a lack of leadership at the national level. EPA really hasn't been at the forefront in promoting something of this level. And so as a result, what has happened is that many jurisdictions who have taken the steps to jump into this arena have done it primarily on their own. The negative impacts that typically happen with that is that the private sector has to go out here and improve its technology in each different state, utilizing different collection techniques, utilizing different standards and such nots. And what this really comes down to is that it's an inefficiency. We've addressed these issues in other sectors, specifically the wastewater sector, the drinking water industry and such. We have good, solid, established protocols and programs for how to measure the water quality results of different technologies in those areas. It's now time to do this in the stormwater sector as well. With the hopefulness that we will avoid this last bullet point right here is death of innovation by 10,000 paper cuts. Current evaluation programs throughout the United States, and this is a rough estimation of various things as part of an effort that the Water Environment Federation has been participating in. But what you can see is that there's a lot of gaps in this particular area. The blue represents areas that have active programs, whether it's state-specific or whether it's something that people might share limited reciprocity with. The program that came out primarily focused on the East Coast, but also initially including California, called the Technology Acceptance Reciprocity Partnership. About 10 years ago, or TARP, is represented by the light blue, with the exception of Lake Michigan in the middle. And these are some of the different states that allow reciprocity through those different programs. Some of the original participating states have moved away from that. California no longer recognizes it. But Pennsylvania, Maryland, and Massachusetts, who are 3 of the original 6, still participate and have that partnership in place. There's also various states, as Kurt mentioned, that also recognize Washington State's program, and even a couple of local municipalities, St. Louis, and we even have one locality in Virginia that actually wrote that into their local stormwater ordinance that they will recognize the Washington program. The need, again, is we need constant application of programs, monitoring protocols that are consistent across the board. For all the differences that we might see with rainfall distribution types throughout the United States and such, the actual collection techniques that are used for water monitoring are relatively standard, easy across the board, and there's really no justification for going out here and having different protocols. The industry would certainly like to see consistency in monitoring evaluation associated with this as well, and in any kind of program that it always has a common sense, meaningful transparency associated with it so that there's not any concerns about backroom deals. The efforts to date as far as what the equipment manufacturers have had is that we began conversations with EPA headquarters staff summer of last year. Due to a couple of personal connections with some folks, we were able to reach out to the senior advisor to the EPA administrator to be able to get a meeting with high-level staff at the agency, which included the Office of Research and Development, as well as the Office of Water. And last year at the WEFTEC conference hosted by the Water Environment Federation in New Orleans was the first meeting of various stakeholders to get together to start talking about a meaningful dialogue in that regards. SWEMA did participate in that effort. From that effort, the Water Environment Federation was charged to form a work group committee that calls itself STEP, for short for Stormwater Testing Evaluation for Products and Practices. This includes a group of approximately 50 different individuals who contacted WEF after learning about this initiative that said we want to participate. No big announcement went out. This is very grassroots focused, but people from across the country came to the organization and asked what was going on, how can they participate. So what happened is that this particular group has worked over the past 6 to 7 months putting together a white paper to illustrate the different issues that are associated with the need for a protocol for an evaluation program at the national level. And there was a follow-up meeting to discuss this at the WEFTEC conference, which the Stormwater Conference or Congress was a subset of in Chicago, but within the last month. A steering committee was formed because it's hard to manage a group with about 50 different individuals to basically help develop the white paper. And these are some of the different areas that the group was charged with addressing. Looking back at the history of various programs throughout the country, try to figure out lessons learned, as well as providing some different ideas for what the framework of national program might look like. We are now in the final steps, which is starting to put together conclusions and recommendations for how to proceed. And that's kind of where I'm jumping the gun a little bit, but in regards to this effort, we did have a follow-up meeting at WEFTEC in Chicago. The unfortunate thing is that EPA was absent because this occurred during the government shutdown. That did happen. The biggest cheerleader and the entity that we need to most fully support this effort just simply wasn't there because the government wasn't operating. And so that is an unfortunate circumstance. We are trying to get a couple of meetings with folks at EPA as a follow-up regarding this. So that was a little bit of a step back. But we're expecting that the white paper will be finally published and publicly available by mid-November with various recommendations. As a result of the meeting at WEFTEC, these are some of the recommendations that are coming out. But effectively, after much discussion, there is consensus that a national testing and evaluation program is feasible and achievable. There is agreement that the states need to be much more engaged than what they are right now. In that regards, what we're seeing is that the steering committee was set up where states were not part of that because we didn't want any state, or we didn't want the perception to be that one state would be promoting their own program over anybody else's. One of the other aspects that came into this is that there's a recognized need that proprietary and non-proprietary systems need to be tested the same way, that there has not been a solid scientific argument provided to distinguish the differences between those two different groups. and that ultimately monitoring is monitoring. As you would imagine, we would need buy-in from various other groups and such, but a common protocol for both the testing evaluation aspect as well as the programmatic process that goes into the evaluation should be looked at and developed. One of the things that came out of this meeting is that there really needs to be a focus about how to make this a sustainable effort. As we heard Ben mention earlier today, the environmental technology verification program that the EPA used to run recently ended over the past year, and that was primarily funded by the federal government. Due to budget cuts and various things that are happening out there, what sustainable models need to be discussed, talked about, in order for a program like this to actually get its legs and be around not just 10 years from now, but 20, 30 plus years. How do you create something like that? And then, of course, we want to have a meaningful engagement and support opportunity where we engage different groups who can actually benefit and utilize these technologies and these protocols that will be developed as a result of this effort. With that, I'm going to step back, and I think that I'll be able to answer any questions that you guys might happen to have for us in regards to how this might relate and where we could also have lessons learned and efforts from Washington apply here as well. Thank you for your time.